And good morning, dear students. So let's welcome you all to the online class. And in today's class, we'll start from question number 10. Now, question number 10. Please read the question. A point P lies on x-axis, another point Q lies on y-axis. So this is my x-axis and y-axis. Capital P is a point on x-axis, and capital Q is a point on y-axis. Okay, please remember P and Q are 2 points which has coordinates. Okay, now when I talk about coordinates, any point, suppose for an example I am taking P out here. If P has coordinates x, y, then the first point is called abscissa and the second point is called the ordinate. The first one is abscissa, second one is ordinate. Okay, now come back to the question. X-axis and y-axis. On x-axis there is point P, on y-axis there is point Q. The question is asking you, number one, write the ordinate of point P. Okay, I know that any point which lies on x-axis is of the form x, 0, right? And any point which lies on y-axis is of the form 0, y. Am I clear with this, boys? I've told this before also. On x-axis, any point, this is 1, 0, 2, 0, 3, 0. So any point x, 0. Similarly, 0, y. Now, what is the question asking you? Find the ordinate of point P. For point P, x is the abscissa, 0 is the ordinate. So what is the ordinate of point P? 0. So ordinate of point capital P is 0. Similarly, for Q, write the abscissa of point Q. Point Q has coordinates 0, y. 0 is the abscissa, y is the ordinate. The first one is always the abscissa, second one is ordinate. So ABSCISSA, abscissa of point capital Q is also 0. First two answers are done. We move to number 3. Okay, what is the question asking you? If the abscissa of point P is minus 12 and the ordinate of point Q is minus 16. If the abscissa of point P is minus 12. Now capital P has coordinates x, 0. What is x? Abscissa. The question is asking you, if capital P, the abscissa of capital P is minus 12, ordinate is already 0, and capital Q, ordinate is minus 16. Ordinate. So 0, minus 16. Find the distance between P and Q. We know how to find. Let's use the distance formula. So PQ is equals to root over minus 12 minus 0 whole square plus 0. Now minus of minus 16 is plus 16 whole square. Are you clear, boys? So therefore minus 12 whole square plus 16 whole square. So minus 12 whole square means 144. 16 square means 256. So if I add it, then this will be 300, 400, right, boys? So therefore 400, I can write this as 4 into 100. Now 4 is also a perfect square, 100 is also a perfect square. So when it comes outside of the square root, it will be 2 into 10. So therefore this is 20 units, which is my answer. Okay, so please pause the video and note it down. Alright, boys, let's continue with question number 11. Now question number 11, 3 points are given to us. P, Q and R are 3 points given to us along with their coordinates 0, 5, 5, 10, 6, 3. So these are the 3 points given to us. We have to prove that these 3 points are the vertices of isosceles triangle, which means that we have to prove that this triangle itself is isosceles triangle. Okay, so how will I prove this triangle as an isosceles triangle? Is that, boys, I'll find the distance between these two, I'll find the distance between these two, I'll find the distance between these two. Now if any of the two sides are equal, then we know that it is an isosceles triangle. So what we'll do, we'll find the distance between this, this and this. Okay, I want to pause the video and I'll show you. Find the distance between PQ, find the distance between QR, and then find the distance between PR. We'll find it. If any of these two values are equal, this triangle will be isosceles triangle. Okay, boys, so pause the video, note it down. Alright boys, so I told you to find the distance between PQ, QR and PR. So to find the distance, it's very easy. We'll just use the distance formula. PQ, 0 minus 5 square plus 5 minus 10 square. Okay, 0 minus 5 is minus 5 square, 5 minus 10 is minus 5 square. Okay, 5 5s are 25, 5 5s are 25, negative square is positive. 25 plus 25 is root 50, keep it as it is, root 50. Similarly, we'll find QR, so this side it is root 50. Okay, we'll find QR also find. Similarly, 5 minus 6 square plus 10 minus 3 square, 5 minus 6, 1 square, minus 1 square. Minus 1 square is 1, 10 minus 3, 7 square is 49, 1 plus 49 is root 50, so hence this side is also my root over 50, okay, this side is also root over 50, so we can clearly see these two sides are equal sides, and whenever two sides in a triangle are equal, it becomes an isosceles triangle. The third one, you also find it out, you will get root over 40, so how to express your answer? You can write on as PQ is equals to QR, triangle PQR is an isosceles triangle. Isosceles triangle, therefore PQR are the vertices of isosceles triangle. Okay boys, so in this way we will have to express our answer. So please pause the video and note it down. Alright boys, we move to number 13. Now number 13 is similar type of question. I'm giving it as homework. I move to question number 14. Okay, in question number 14, A, B, C, D, 4 points are given to us, and we have to prove that these 4 points are the coordinates of a square. Sorry, vertices of a square. So if it is a square, all the sides has to be same. So distance of this has to be same. You have calculated distance between AB and BC. They are already equal. Okay, AB. See, whenever you need to find AB, use the distance formula. 5 minus 1, 4 square. 4 square is 16. 6 minus 5 is 1 square. So 1 square is 1. 16 plus 1, 17. In order to find BC, 1 minus 2 is minus 1 square. 1. 5 minus 1, 4 square. 16, so 17. Similarly, CD. Okay, if I need to find CD, 2 minus 6 is minus 4. Minus 4 square is 16. Plus 1 minus 3 is minus 1 square is 1. So already it is root 17. Okay, so if you know, you can do it directly also boys, no problem. DA. Now DA, 6 minus 5, 1 square, so 1. Plus 2 minus 6 minus 4 square, 16. So root over 17. No, not only till here. Remember boys, if it is a square, then the diagonals are also equal. The diagonals also has to be equal. So let us calculate the diagonals now. D-I-A-G-O-N-A-L-S. Diagonals. AC will calculate first boys. AC. So AC means 5 minus 2. How much? Okay, let's write 5 minus 2 whole square plus 6 minus 1 whole square. Okay boys? So 5 minus 2 is 3. 3 3s are 9 plus 5 square. 5 5s are 25. So 25 plus 9 is 34. Keep it as it is. We'll calculate BD. BD. Alright boys. So BD, your AC is 34. Huh? Root 34, sorry. Now BD also should be root 34. Okay, then only it will be a square. So BD means 6 minus 5. 6 minus 5 is how much? Sorry, 6 minus 1. 6 minus 1 is 5. 5 square is 25. Plus 2 minus 5. How much? 3. Minus 3. Minus 3 is square is 9. Okay, I hope you're clear with this. So root over 34. So now we can see all the sides are equal. The diagonals are also equal. So hence ABCD is a square, no doubt. Hence ABCD is a square. Okay boys, so whenever we need to calculate or check or prove whether it is a square or not, first of all the sides has to be same, but the diagonals also has to be same. Okay, but whenever we calculate a rhombus, diagonals are not same. Rhombus, boys, rhombus will be something like this. Okay, all the sides are equal, but the diagonals are not equal. This will be in case of RHOMBUS, rhombus. This is square, this is rhombus. So with that point, boys, your assignments for today will be number 13 and as well as question number 15. So please complete all your assignments along with today's work and submit it by tomorrow. In number 15, we have to prove it as rhombus. Okay. So I hope so far you people are understanding. And if you're understanding, please don't forget to press the like button and subscribe to my channel. Okay, like button. Okay, so that I can understand. Yes, you people understand. Okay, so that's it for today. I'll see you tomorrow in the next one. Take care.